Assalamualaikum and a very good day. So our chapter is going to be chapter 5 today, allocating resources to the project. But in the book Project Management in Practice of Mental, it will be in chapter 6. Okay, and we are also using other references, which is chapter 8 and chapter 9, Project Management and Managerial Processes. Okay, so you can refer this in the books. Okay, this chapter actually will address methods that are available to project managers in order to deal with resource utilization and availability. Okay, so the technique that we use here is resource leveling and resource constraint schedule. So two techniques. Okay, so up to now, the start and sequence of activities has been based solely on technical or logical consideration. So in the previous chapter, uh, we have seen the scheduling, we have seen part of the planning. So we have seen the work breakdown and allocation. So these are activities that has been based solely on technical and logical consideration without considering the constraint in terms of scheduling, such as resource constraint or time constraint. Okay, so this chapter will address that. Okay, so we'll look into some of the overview of resource scheduling problem. Okay, we have resource schedule problem. So what those things come into project manager's mind when all the stuff and other resources are already assigned. Okay, so these are some of the problems that project managers should think about. Okay, how much flexibility do we have in using our resources? Okay, do we unforeseen resource dependency will exist, or is there any new critical path that will exist? Is the original deadline realistic? Will outside contractors have to be used? Will the assigned labor or the equipment is adequate and available to deal with my project for the whole of the period? So these are the questions that should be asked by the project manager. Okay, though staff and resources has been assigned. Okay, so project planning process that we've done before this and we should look into again is when we have a scope or work breakdown structure, we did draw the network diagram using the earliest start time, estimation of the earliest start time, late start time, duration, floats that we have calculate. Okay, uh, late finish time, using the forward and backward technique of the networking. Okay, now after we have the network diagram, we start to look into the resource and cost scheduling. Then we have a master plan after that. But all these four diagram processes is not a risk free. Means that we have to look into the risk that will exist there. Okay, so that if we have, these are some of the resources problems that we have to look into. We have resource and priorities. Okay, so we need to look into the project network times are not a schedule until we will see that the network time is not going to be a schedule until resources have been assigned. The estimation cost is not a budget until they have been time phased, means that a proper planning. Okay, so we'll have two resources problem that we will encounter. One is a resource constraint scheduling. Okay, so whereby the duration of the project is flexible, but the resources is not flexible. Okay, the other one is that resource smoothing, whereby we have a flexible resources but time is not flexible. So for this resource smoothing, we might adapt a technique using demands and using Slack, so we might delay some of the non-critical activities. Okay, so we'll look into types of project constraints. First is the technical constraint. The technical constraint, which is related to the network sequence in which project activity must occur. This one we've done technical constraint. We look into when we do the we do the network diagram. Okay, the position or the network sequence. Okay, and technical constraints means that, for example, we have a sequencing of activity that cannot be rearranged. Means that, for example, if we start a project, let's say building, constructing a building, when we start, we have to pour. When we starting, we have to pour all the base. After that, we do the frame. After we finish the frame, then we do the roof. Then we end the construction. Okay, or we do a project dealing with the programming. So we start to design at the beginning. After we design, we start to code, and then after that, then we can test and end. We cannot technical constraint project. The second activity like coding or third activity like test cannot come before the first and second activity. Okay, so resource constraint is dealing with limited resources. Okay, we are in the absence or shortage of resources. So if that's happened, we can the diagram still can be, or the process still can be readjust. The non-technical process can be delayed for some of the activities. Okay, and then particular sequencing also is not critical in resource constraint um, types of project constraint. Okay, while resource constraints or physical constraint, some of the activities cannot occur in parallel. Okay, so we'll look into some of the types of resource constraints that we mentioned before. What are the resources involved in project management? Resources that involve in project management are people, materials, and equipment. People normally, when we deal with human resources, okay, so we need to look into not only how many people that we use in our project, we also have to look into their different skills, okay, and the complexity of the project scheduling, how we can move around people in our scheduling according to their skills, not only by how many people. So both of them are very important, numbers of people and the technical skill that they have. Okay, so material, the second one is materials. So scheduling material also very important in developing products. Okay, this not enough raw materials, not enough materials that to be used during our process will hinder the time to market of our product. Okay, shortage availability, this has been blamed for the delay of many projects before this. Okay, so another constraint of resources are equipment. Okay, so the equipment is usually presented by type, size, and quantity. Okay, so sometimes people don't look into equipment as resources, and this is very problematic. We should look into equipment of part of resources that can become a constraint in our project. If let's say we don't have enough equipment to do a parallel project at the same times, if we have a parallel network diagram, so this will become a resource constraint. For example, we have here, so our equipment for what is this? Yeah, or this is a glove factories. Okay, currently we have 21 glove factories, for example, and we only have 458 lines. These are our equipments, means that this is the constraints of our equipment. We don't have 600 lines. We don't have 700 lines. We only have 458 lines of people producing glove for the factory. And then these are the product that we need to produce. This is the capacity, the maximum capacity of the product per year. Okay, this is limited for 44.8 billion pieces per year. So if let's say during the coronavirus time like this, we need more glove. Okay, we need more than, let's say, 50 billion pieces per year. So this has become a constraint for us. So we need more raw material to produce more than 50 billion pieces per year, for example. Okay, means that we need more equipment to run it. Okay, so these are the people, number of employees. Okay, so 11,000 at one time, only 11,000 employees that are hired. Maybe this is based on cost, or maybe this is based on the capacity of the factories. Okay, so these are the examples of equipments, materials, and also manpower. Okay, so what are the scheduling problem that we could face? As I mentioned before, we could have time constraint scheduling problem, or we can have a resources constraint scheduling problems. There's two type of constraint for scheduling problem. So time constraint means that the project should be completed by the time given. Okay, so the time is fixed, but resources can be some sort of flexible. Okay, while the resource constraint scheduling problem will have a limited level of resources. Okay, well, but the flexible time. So how do we determine this? Okay, if the critical in a network diagram, okay, how can we determine this? If the critical path is delayed in a network diagram, will resources be added to get back on schedule? If resources is added to get back in schedule, yes. If we answer yes, we can add more resources, then we'll say it's a time constraint scheduling problem. But if resources cannot be added, means that we have to delay the time, then it is a resource constraint scheduling problem. So we have two types of scheduling problem, time constraint and also resources constraint. Okay, so let's say in allocating resources, we have some of the assumption. Let's say the first is that the splitting activity is not allowed. We cannot split activity, means that we cannot delay of the activities. Okay, so we cannot put one start activity, we stop, pause, do other activities and start another activities. Okay, let's say. And then level of resources used for an activity cannot be changed. So here the limiting assumption, level of resources used for an activity cannot be changed, means it is a time constraint. So in the risk assumption, activities with the most like pose the least risk. Okay, reduction of flexibility does not increase risk. The nature of an activity or easy complex doesn't increase risk. Okay, so let's see. So the resource, because it is the level of resources used for an activity cannot be changed, we say it is a time constraint project. In a time constraint project, smoothing resources demand, what are we going to do with this method, smoothing resources demand? It must be completed by an imposed date. Okay, time constraint project. It requires use of leveling technique that focus on balancing or smoothing resources. Okay, we might use some of the positive slack in order to delay non-activities to manage resources utilization over the duration of the project, so that we don't add more time to the project. Okay. For example, we have a botanical garden project. Okay, so we are not using okay, let us see this example botanical garden project. We are using a Gantt chart type of diagram. Okay, so not a network diagram like before. This is a Gantt chart network diagram. Okay, so let's say we have 1, 2, 3, 4, 5, 6, 7 activities: design, layout and clarify, walkways, lighting, irrigation, fence and walls, and planting. Okay, so we are allocated with 2 backhoes. Um, sorry, we will look into resources, which is the backhoes used in the botanical garden project. So this is a top bar chart using the activities on the time scale. Okay, so we can see that for layout and clarify, we start with a design. Design doesn't use backhoes. Okay, so and the design only take 1 days. Okay, then after the design, then layout and clarify can start. Layout and clarify cannot start before the design. Okay, so layout and clarify need to have 2 backhoes for day 1, day 2, day 3, and day up till until day 4. After that, 3 parallel activities can be done after the layout and clarify, which is walkways, irrigation, fence and walls. Okay, so these 3 activities can be done concurrently, and they took day 4, 5, 6, 7, 8, 9, 10, which is 7 days to finish the whole activities. So walkways require 1 backhoe, irrigation require 1 backhoe, fence and walls require 2 backhoes. Okay, when these 3 activities finish, then the lighting can be installed. Lighting will take place for 8 days. Okay, sorry, for 7 days from day 10 to day 16. Okay, then finally planting will take place after lighting. Okay, so from day 16 to day 24, and it requires 3 backhoes. So you can see that we have 3 slides here. Oh, sorry about that. The lighting can only be done after the walkways is done. You can see the activity, but it's not dependent of irrigation and fence. Lighting is not dependent on irrigation and fence. Okay, so that's why irrigation and fence have the slack days here. Okay, activity slacks here from day 10 to day 16. Okay, 6 days. Okay, now let us see. And we start to plot the histogram of the resource profile for the backhoes. Okay, if you see that for 1 day for the design, we doesn't need any backhoes. Then we start to do layout and scarify for day 1 up to day 4. Okay, after we do the design, and it needs to use 2 backhoes. So 2 backhoes, number of backhoes required is 2 for day 2, sorry, day 1 until day 4. Okay, next. 3 activities can run concurrently, and all of them can only be done after the layout and scarify, which is they are all interdependent of layout and scarify. They cannot come before the layout and scarify. Have to come after the layout and scarify, and they can be done concurrently. Okay, so we plot them. Okay, 2 backhoes for one of the activity, 1 backhoe. So 2 backhoe for the fence and wall, 2 backhoe for the fence and wall, 1 backhoe for the for the irrigation, one backhoe for the walkways. Okay, so this is the resource profile. So after, sorry, and then we'll see the lighting. The lighting can only be done when walkways are finished. So see the interrelation diagram. Okay, but they are not related. They are not depending on irrigation and fence wall, and they requires one backhoe. Okay, so they requires one backhoe from day 10 to day 16 for 7 days. Okay, 6 days. Now finally, finally, 3 backhoes are required for planting from day 16 to day 24. Okay. Three backhoes is required. So let's say we actually have a time constraint that we need to finish our the resource leveling or smoothing that we can adapt here is that we can move the activities with the least risk, which is the most lags, to different date, delay the activities. This is what we call resource smoothing, okay, without adding more times to the project. Okay, this is a time constraint type of activity. Okay, so let's say we at one time we can use only 3 backhoes and we have to finish within 24 days. We can see that we have slack here. Okay, activity slack here for irrigation and fence and walls. So we can actually delay them. We can see that the critical path is here, yeah, from the design to layout, scarify, walkways, lighting, and planting, because they don't have any slack. So they are the critical path here. The one that have slack is irrigation and fence and wall. So we can move this activity as long as we don't exceed the planning time. Okay, so means that we can move the fence and wall, which is using the 2 backhoes, and we can move the uh, irrigation. Okay, so with that, okay, level of smoothing, only 2 backhoes that we use. One of the backhoe for the fence and wall is moved to day 10 to 16. Okay, so only leave with 1 backhose. Another backhose for the irrigation is moved to day 10 and day 16 also. So only left with 2 backhoes, one for the critical project, which is the walkways, and another one is for the fence and wall maybe. Okay, so with that we are doing the resource smoothing. This is what we call resource smoothing. At one time, not more than 3 backhoes is used, and we can still finish on time, which is day 24. Okay, so this is what we call resource smoothing. By delaying the fence and walls activity, or the the irrigation process. Okay, so resource allocation methods, resource demand leveling techniques for time constraint projects. So what are the advantages and disadvantages? The advantages of this resource leveling is that the peak resource demands are reduced. Okay, the fluctuation in resource demand is minimized. Resources over the life of the projects are reduced. Okay, but the disadvantages is that we lose flexibility that occurs from reducing the slack, increases in the critical of all activities. So we can see that we reduce the critical path already because we move the fence and walls here, let's say, so we reduce one of the slack. Okay, so we increase the risk. After this, fence and walls cannot be delayed anymore. Okay, it doesn't have any more slack. We only left with one slack. Okay, that's what it calls by increases in the criticality of all activity and reducing the slack. Okay, now after we finish the time constraint method, let us see some of the resource constraint scheduling or project, whereby the resource are the constraints as the name implied. Okay, so resources are limited in quantity or availability. Okay, activities are scheduled using heuristic rules of thumb. Okay, so this is a rule of thumb. You have to look into the minimum slack first, and then you have to choose the smallest duration, and then you can choose the lowest activity identification number. We'll see how this come into. Okay, the scheduling, priorities for the scheduling has to come with a minimum slack first, and then if we're done with the minimum slack, we look into the smallest duration. Then if we're done also with the smallest duration, we look into the lowest activity identification number. Okay, so the parallel method is used to apply heuristic. Okay, an iterative process starting at the first time period of the project and scheduling period by period the start of any activity using the 3 priority rules. These are the priority rules that we gonna use. It's okay. We can look into the example after this. Okay. Okay, let's see here. We have a network diagram of one of the activity here. Okay, so let us have a look at the legend that we use, the node legend here. If we can look at this example, the events and activities are on nodes, not on arrows. Okay, so what are the legends that we use here on our nodes? Here is the earliest start, and then we have identification number, and then here is the earliest finish. You can see that the forward process is here, and then the backward process is here. Okay, this is the latest finish, the duration that the event will take place or activities take place, and this is the latest start. Okay, the calculated slack is here, and number of resources that we're going to use in every of the activities is placed here. Right. Now we take a look at the critical path. We can see that activity 1, 3, 6 is the critical path, and 7 is the critical path because they don't have any slack, they have 0 slack. So the critical path is 1, 3, 6, and 7, whereas 2, 4, 5, and 6, 2, 4, and 5 having slacks. They are not critical. Okay, so 2 have 2 slacks, 4 have 6 slacks, 5 have 2 slacks. Okay, so 2% is allocated for activity 1, 2% is allocated for activity 2, 2% is allocated for activity 3, 1% is allocated at activity 4, 1% activity 5, 1% activity 6, and 1% at activity 7. So we will have 3 parallel activities at one time after we finish the activity 1, which is 2, 3, and 4. Whereas activities 5 and 6 very dependent to activity 3. They can only start after activity 3 finishes. Okay. Then activity 7 can only start after all the activities finishes. Finish 1 until 6. Finish. Okay. So we can start load chart for the earliest start of the